CEASIOMpy includes all its modules are pre-installed and compiled in Conda environment. So every time you work with CEASIOMpy, you must first activate Conda environment. Here we open a terminal and type conda activate CEASIOMpy. Then you can see CEASIOMpy inside a pair of brackets at the beginning of this command line, which means your conda environment for CEASIOMpy is activated. Then CEASIOMpy conda environment is activated. We can start CPACSCreator by simply type CPACSCreator. Now we have CPACSCreator started. This is the aircraft geometry modeling tool that we use for modeling aircraft geometry.
Now we will work with CPACSCreator. This user interface is quite typical as most of the CAD modeling tools, and it's even simpler. On the left panels, there are viewing functions. You can, for example, have select component, select functions, the panning functions, rotate, zoom in, fit to screen, and also can have one-click functions to have the conventional aircraft 3-view position, the front view, and the top view, the side view, and the front view. Now I open a provided CPACS file, which is in XML file, of course. It's a very simple wing and body configuration. You can save the file by click save here or save here. You can do save as to whatever location you want and the file name that you gave. You can also close all the open files. Note that if you open several CPACS files, they will be overlapped to each other if you don't make specific actions. Now I reopen these files again. On the right panels, there are editor windows. If we click the fuselage, the editor asks you whether you want to make new fuselage, add a new fuselage, or delete current fuselage. We can check or uncheck this editor window and the trees from here. The editor will display. We check editor. The same for the trees. Now let's look at the aircraft body on the fuselage. You can see a bit hierarchy here. At the top level, its name is cigar. It has fuselage length, width, and height. And also it defines the nose center coordinates. You can of course change this so that you move the entire fuselage. For example, you change the nose center x coordinates so that you move the fuselage a bit afterward. You change it to 10. Remember, every time you change a parameter, you must click OK so that the change is applied. From the GUI, you can directly see how the change takes effect. You can also change the fuselage length, which is the total length of the fuselage. Note that the height and the width numbers here, they are the maximum height and width of the fuselage. Other sections will be scaled from it. And one more thing is, there is a very handy function called in editor undo function. So if I click undo, the nose center is back to 0. So I got the geometry that I opened before. The fuselage is composed by sections. In this section editor, you can click on each section. The corresponding section is highlighted. Each section is actually a number of points, which form a circle or an ellipse. Those points are stored in the CPACS file with section profile ID corresponding to it. But in CPACSCreator user interface, it is very simple and straightforward to directly view every section, and change it by some higher level definition. For example, the section of the circle's height, width, or total area. For example, if we change its total area from 52 to 80, let's say. Remember to click OK so that the changes apply. We see a little bit fat section here. Do the same for other sections if you want. The positioning editor is to set positions for each section. Here, the length means that the relative length or the relative distance between two sections. For example, if we choose this cigar positioning for ID and its length is around 70, from UID cigar session 1 ID to cigar session 4 ID. That means length 70 is between those two sections. We can change it to 25. Oh, not 125. We can change it to 25, for example, and then click OK. Oh, so that then this cigar session 4 ID is moved backward along the fuselage so that we see a thinner fur body because the session is not changed for cigar session 4, but it's just the relative distance to the first session is changed. Note that the difference between setting position using the section editor, here is the section editor, and the position editor. If we go back to cigar session 4, we can see that its x-coordinate is 25, as we changed the relatively length as 25. And if we change it back to 70, okay, now it's back to what we had before. You can try out this by yourself in a similar way. For example, add a section and define this section's width and height and its positionings.
Now we proceed in working with CPACSCreator. In previous session, we went through the fuselage. In this session, we will exercise with wings. We will get familiar with the wing parameter and how to change them, how to create a new section of a wing, and how to create a new wing. The wing has a very similar hierarchy as fuselage. It also consists of sections. Each section is positioned by positioning parameters. However, the wing has a much higher level parameters to play with, as we can see here in the wing editor panel, which is very good for aircraft design. In this example, we only have one wing. Usually, aircraft has several wings. It is the same way to define one wing and more wings. Or rather, we call them tails. In the wing editor, we can see the parameters. The root leading edge coordinates is actually where we place the wing. We can change, for example, the x coordinates a bit forward from 31 to 25. Click OK. Now we can see the entire wing is moved a little bit forward. The rotation around x, y, z axis you can also define, especially if the wing is rotated around y-axis. We usually say this wing is twisted. It is quite common that the aircraft main wing section is twisted along y-axis. For vertical tail, for example, is a non-symmetric wing rotated 90 degrees around x-axis. Note that this aircraft is symmetric, and its symmetry plane is xz plane. If we turn off the symmetry, click OK. The wing starts to define from the positive y-axis, namely what we call starboard. Now we turn on its symmetry plane. The sweep angle you can change here as well. The wing sweep is very important to reduce the wave drag. You can change the sweep angle with respect to a certain percentage of the chord. The most conventional use is to define the sweep angle with respect to a quarter or 25% of the chord. We can change this to 45, for example, sweep angle. Another conventional use is to define the sweep with respect to the leading edge line, which means the 0% of the chord. Diageo is another parameter that you can control. To view the Diageo effects that you apply, it is better that you change to front view. And now back to Diageo. We can change the Diageo angle from 0 to 5 degrees, for example, and click OK. Now we can see there's a 5-degree Diageo here. Now change the wing back. Below we see top area, which is the wing projected area or the wing area from the top view. Whatever is called, it is actually the wing area. And the followed wingspan, aspect ratio. Note that the top area and span here are both referred as half wing, since we only defined the half wing and the rest of the wing is mirrored around xz plane. To design or change the shape of the wing, you can, for example, keep the wing area constant and change the span from 34.59 to, for example, a longer span, 40. Click OK. Now we can see the aspect ratio is automatically calculated according to the fixed wing area and the span that you defined. So the aspect ratio gets increased. The last parameter that you can control is the airflow view. Here we have NACA 0012. If you change one here, that means you change all the airflows in this wing. All the airflows in all the sections in this wing. We have NACA series built in database. For example, if we want to change this to a thinner airfoil, NACA 0006, we change it here. And we click OK. Now we go to all the sections, or both sections. We see the sections profile is also changed to NACA 0006. You can, of course, change the profiles for each section, and every section has a different airfoil. This wing we only have two sections, the root section and the tip section. It is okay for a simple wing, but most of the wing has many sections. You can add a section by clicking on Section Tree, Add Section. It will ask you where you want to add this section. We want to add a middle section. So we select after the root section, which is this one, section 1. And then we click OK. Now we can see a new section called CPACS blah 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 wing section 1 bis is added. And if we select this section, it's highlighted here. And if we change its x coordinate a bit aft from 22 to from 52 to maybe 56. Click OK. Now you can see there is a kink is created. And also we can change its chord lines to a bit smaller. Maybe from 12 to 10. We do this by changing its width. You see here, which is the width of this particular section. We click OK. The width is not very conventional way when we talk about the wing and the wing section. But anyhow, it is very straightforward if you consider only geometric information. This usually means the chord lines we are talking about. Now we change to the top view, and we can see a wing with one kink in the middle. You can, of course, delete this wing section. Delete the section. We can select the section that we want to delete. Bis. Click OK. Now the wing section is deleted. We are back to what we had before. Following, we will exercise how to add a new wing. Here, we would like to add a vertical tail. We select the wings. There is Add New Wing. In the dialog box, type the name of the wing in the UID. We call it rudder. Choose the number of sections. We keep it simple, and we just choose 2 sections, 1 root section and 1 tip section. The airflow, choose the airflow you want. we want still knockout 12. And then we click OK. A new wing is created, it's called rudder. But this one would be very small in comparison with the entire aircraft. So we hardly see it. It's here. It's very small. If we click on the rudder, we see its editor, wing editor panel. We could see its area is only 1. Remember the main wing that we have the area around 450. Now we will start in the wing editor and go through all the settings that we went through before to edit the rudder. First, we will give the root leading edge coordinate and wingspan and area so that we can see the wing. We give the root leading edge x coordinate 670 and keep aspect ratio constant at 2. We have the area, for example, 200, and click OK. Now we can see a rudder lying on the surface, lying on the XY plane. This is not what a vertical tail should look like. We now will rotate this around X axis for 90 degrees. Click OK. Now it's like something. We will now change the tip chord to a bit smaller. We go to sections of the rudder. This is the root chord. We go to tip chord. Again, the chord length is called width here. We change this to a smaller value from 14 to maybe 9. Click OK. Now see a reasonable vertical tail. From the similar place of adding new wings, from the wing, click wing, you can delete existing wing. And then you can select which wing you want to delete. Here we have those 2 wings. But now I don't want to delete any wings for now. For your own exercise, you can add a horizontal tail by yourself so that you can have a conventional aircraft with a body, a main wing, a vertical tail, and a horizontal tail. When you finish your design or your drawing of aircraft, you can do save as. You can save to a new name, version 1, for example. Click save, and then your saved file or your open file name appears here. Okay, now it's your turn to exercise with CPACSCreator to make aircraft on your own.